Hey y'all, welcome back. Tonight's homework is all about solving linear equations. And there are quite a few problems on here, and so I'm going to work them rather quickly. But if you have more in-depth questions, definitely check out the lesson video that I posted from the lecture that was given in class. I go into a lot more detail as far as what the names of the properties are and when to use them and all that. In this homework video, I'm really just going to be working out the problems one at a time without a full explanation of what's going on. So I'll still narrate the steps that I'm doing, but I am going to move a little faster than I did in the notes. So let's start with number one. The first few problems are all one-step equations, so you should only have to use one property of equality to isolate the variable. Number one, we are going to subtract 4 from both sides of the equation, which will give us our answer right away. These one-step equations are pretty nice. Negative 12 minus 4 is negative 16. And there you go. Now, one thing I will note before we go any further is that you should have access to at least a 4-function calculator on the TSIA2. So I'm going to allow you to have a calculator on all these problems, even if the math is pretty easy. Particularly when we have negatives and fractions, definitely want you using the calculator to make sure you don't make any mistakes with the arithmetic. Okay, you'll have enough to think about as far as the algebra is concerned. We don't need the arithmetic to get in there and mess you up as well. Okay, number two, we've got p minus 6 equals negative 5. For this one, we're going to use the addition property of equality to cancel out that minus 6. So negative 6 plus 6 is 0. Those are going to cancel out on the left-hand side, which is what we want. So we just have p equals negative 5 plus 6. Go ahead and type that into the calculator. You should get 1. For number 3, we've got 3 plus p equals 8. I'm going to subtract 3 on both sides. Get rid of that 3 so I get the p by itself. And so here we've got p equals 8 minus 3 is 5. Number 4 is v minus 15 equals negative 27. So we'll undo that subtraction with addition and add 15 to both sides. Negative 27 plus 15, definitely want to use a calculator there, but we do get, what is that, negative 12. Number 5 is 10 times n equals 40. I'm actually recognizing some of these problems. I think I might have got a little copy-paste happy from the notes to the homework, but that's okay. It's still good practice. We're going to divide both sides by 10 here. The inverse of multiplication is division, so we want to use that division property of equality, and we get n equals 4. By the way, as I'm citing these properties of equality, please know that you do not have to know the names of those properties. As long as you know that to manipulate an equation, whatever you do to one side, you have to do to the other, that's really should be your takeaway from all the properties of equality, whether it's addition, subtraction, multiplication, division. The same kind of rule applies. Sorry about that, Bill. The same rule applies where you have to do the same thing to both sides. So like with number 6, if I want to get rid of that divide by 11, I need to apply the inverse property, the inverse operation, multiplication, use that multiplication property of equality, and multiply both sides by 11. 6 times 11 is 66, so k equals 66. Number 7 has negative 15 times x. Just as a little reminder, when you don't see an operation in between the number and the variable, it is implied to be multiplication. So this is negative 15 times x. So to undo that, you might be tempted to add 15 to both sides if you don't catch that. But really, we want to divide both sides by negative 15. Now, luckily, the arithmetic is actually nice here because you have 0 divided by negative 15, and 0 divided by anything is just 0. So we get x equals 0. Number 8 says 21 equals negative 7 times n. So just like with the last one, we're going to want to divide both sides by negative 7. We do end up with our variable on the right-hand side, but that really isn't a problem. It's okay. And normally I like to get it on the left-hand side, but if it's just over on the right, you could just leave it there. We get negative 3 equals n. If it really bothers you that the variable's on the right-hand side, which it really shouldn't, but if it does, you can always just rewrite it like this. Number 9, says negative 13 equals m divided by 4. So m being divided by 4, we want to get rid of that divided by 4. We need to multiply both sides by 4. Another opportunity to use your calculator here, even though you might be able to do negative 13 times 4 in your head, or even if you could write it down and do it, don't waste your time. Our goal here is to pass that TSI, and you get a calculator, so make good use of it. M, or I guess I'll leave it over on the right-hand side because that's where it is, negative 52 is M. Again, if you want to rewrite it, you can, but you don't really have to. Okay, moving on. Now we're incorporating some combining like terms. So we're going to pull together all the like terms first before we start using properties of equality. So number 10, see we've got 9x and negative 6x. When you've got two terms that are on the same side of the equation, meaning both on the left or both on the right, and they both have an x, you can put them together. If both terms do not have an x, you can't put them together. Oh, wait, I think I misspoke there. If they both have an x, you can put them together. If they both don't have an x, you can put those together, those constants. But if one has an x and one doesn't, you can't combine those. So like I can't combine negative 6x with 15, for instance. So 9x minus 6x, if I have 9 x's and then 6 of them go away, I'm left with 3 x's. So 3x plus 15 equals negative 12. This is what's known as a two-step equation, and this is going to require two separate steps, two instances of properties of equality, two different properties of equality, but they both basically work the same way. The only real question here is which order to do them in. Like, do we want to get rid of that plus 15 first, or do we want to get rid of the times 3 first? On these two-step equations, you always are going to get rid of the addition subtraction before the multiplication division. So firstly, I'm going to subtract 15 from both sides, which will be 3x equals negative 27. Then I can divide both sides by 3 and get x equals negative 27 divided by 3. Sorry. Oh, yep, I typed in the wrong thing. Divided by 3 is negative 9. Oh, I should have known that one. Okay, number 11. Number 11, just like number 10, has two like terms. On the left-hand side of the equation, we've got this negative 2x minus 10x. Negative 2x minus 10x is negative 12x. Plus 12 equals 18. Now we've got a two-step equation. We'll take care of that addition first. We're going to subtract 12 from both sides to get rid of that plus 12. And now we have negative 12x equals 18 minus 12 is 6. Then I'm going to divide both sides by negative 12. And it looks like I get a fraction here. No big deal. Sometimes you get fractions, sometimes you don't. You're going to use a calculator, so you're not going to worry about it. Negative 1/2. Or if you write 0.5, that works just as fine. Number 12, once again, we've got two like terms. 6c minus 2c. Notice they're not next to each other, and that's okay. You got to look at the whole equation there, or the whole, on that expression, I guess, on the left-hand side of the equation. Whether or not they're next to each other doesn't matter. You can still combine them like we did the other two problems. So 6c minus 2c is 4c. So 4c minus 8 equals negative 16. Then we can add 8 to both sides, leaving us with 4c equals negative 16 plus 8 is negative 8. And then finally, we're going to divide both sides by not by negative, but by positive 4. So c equals negative 2. All right, so that's how combining like terms works. Typically, when you have an equation set up like this, you want to do the combining like terms first and get it down to a one or two-step equation. If you've got a two-step equation, then you're going to undo the addition subtraction before the multiplication division. Okay, just some more practice here, kind of just mixed two-step equations. Number 13, we do have a little bit of combining like terms here. Let's go ahead and combine that 13n minus 4n. So 36 equals 13 minus 4 is 9, so 9n. Then we'll divide both sides by 9 and get 4 equals n. or n equals 4 if you prefer to write it that way. Number 14 is a two-step equation. There's no like terms here, so we don't have to worry about combining any like terms. First thing we're going to do is subtract 3 from both sides. So I have negative 2n equals 6. Then I'm going to divide both sides by negative 2 to get n equals negative 3. Number 15 has some decimals thrown in, but don't be too worried because, again, you get to use the calculator, so don't let those decimals or those fractions or those negative numbers or whatever typically gives you a hard time in the arithmetic department. You should not have to worry about that when you take the TSI. So 2.5x equals 15. We're going to divide both sides by 2.5. So 15 divided by 2.5 is 6. And I didn't do that in my head. I have got a calculator out to the side here that I'm using. And I encourage you to do the same thing. Number 16, 17, 18. It looks like, yeah, all the way through 21 at least, these are all going to be two-step equations. So 16, we're going to start by subtracting 7 on both sides. Now I've got h over 2 equals 3. Multiplying both sides by 2, it's going to get rid of that divide by 2 that I don't want. And so then I have h equals 6. For number 17, I'll start by subtracting 8 on both sides. Then I'll have b divided by negative 4 equals negative 3. Then I will multiply both sides by negative 4. Now this notation looks a little weird, so because I'm multiplying by negative, I don't really have to put these parentheses here, but I feel like it kind of makes it a little easier to read, so you're not confused on, like, am I subtracting or what's happening there? So anyway, I do want to multiply both sides by negative 4, and I get b equals 12. Number 18, I'll start by subtracting 9 on both sides. Notice how I'm getting rid of the addition and subtraction. I'm getting rid of that constant before I get rid of the coefficient. The coefficient is the number that's in front of the variable, and the constant is the number that does not have the variable on it. So 9n equals, well, 9 minus 9 is just 0. And then if I divide both sides by 9, 0 divided by anything is 0. So, it doesn't hurt to put it in the calculator, but hopefully you can just get that one with that one. Number 19, and then 19 through 21, all two-step equations, and that looks like a 22. Starting with 22, we start throwing in some distributive property. So number 19, I'm going to subtract 4 from both sides. So now I have negative 4 equals n divided by 5. Then I'm going to multiply both sides by 5 to get that n by itself, to isolate the n, and so I get negative 20 equals n. Number 20, we'll start by subtracting 1 from both sides, using that subtraction property of equality. Negative 9x now equals negative 81. That'll divide nicely. We want to divide both sides by negative 9 to get our final answer here. X equals positive 9. A negative divided by a negative is always going to be positive. For number 21, we'll add 2 to both sides. Start off with that. Negative 6 plus 2 is negative 4 equals n divided by 2. Now I will multiply 2 on both sides to get negative 8 equals n. Okay, let's start throwing in some distributive properties. So the distributive property is a property that explains how multiplication and addition interact with each other. So I'm going to erase this, but just so you can kind of see the general format here. If you've got something in this form, and that might be plus, it might be minus, it works basically the same way. You're going to multiply whatever number is out here by each term that's on the inside. So we'll have a times b plus a times c. And so that's what the distributive property is. If you ever have a linear equation that you're trying to solve that has a set of parentheses and kind of looks like that, you will use the distributive property, and you usually want to do that first. So with number 22, I'm going to apply the distributive property and multiply 4 by z plus 5 and get 4z plus 20 equals 32. Then I'm going to subtract 20 on both sides, giving me 4z equals 12. Next, I'll divide both sides by 4. And get z equals 3. For number 23, be careful with that distributive property. Make sure that you distribute that negative along with the 2. Sometimes it's easy to miss that. So we are going to multiply both of those terms on the inside of the parentheses by negative 2. Negative 2 times 4 is negative 8. So negative 8g. Negative 2 times negative 3 is positive 6. And I'm going to subtract 6 from both sides. That gives me negative 8g equals 20, would that be 24? 30 minus 6, just doing a double check here. Yeah, 24. Divide both sides by negative 8 to get g equals negative 3. Number 24. This one's going to have not only the distributive property, like we had in 22 and 23, so we are going to distribute that 5. But then you'll notice we do have some like terms that we need to combine. Okay, we've got 2 constants on the left-hand side, 6 and 5. And we can add those together. 6 plus 5 is 11. So we've got 11 plus 5m equals 26. Then we'll subtract 11 from both sides. Get 5m equals, would that be 15? And finally divide both sides by 5. M equals 3. Okay, moving on. Now, if you've got, it looks like starting with number 25, we are starting to get some variables on both sides of the equation. So we haven't seen that yet. I mean, did see some in the lesson and when we took notes the other day, but we haven't seen them in the homework yet. So when you do have variables on both sides, you're just going to use the properties of equality to bring them all over to one side. Usually, I like to bring them over to the left side if I have the choice, but you're welcome to bring it to the right-hand side if that seems like it's going to be easier for you. So with number 25, I'm going to start here by adding 3x to both sides. And this one's already kind of weird because negative 3x plus 3x is just 0. And so it's not really a problem, but just if that happens, you're just going to have 0 on that side. But now we see we've got a 2-step equation, and we can solve it like we did all those previous problems, the 2-step ones that we already did. We can add 7 to both sides to get rid of that constant. So I have 7x equals 7. And then I can divide both sides by 7, which is called the coefficient of x. So 7 divided by 7 is 1, so x is 1. Okay, number 26. Same kind of deal here. We've got variables on both sides, so we need to collect them all on one side. So I'm going to subtract 3b on both sides to get rid of all the b's on the right-hand side. 8b minus 3b is 5b, so I get 5b plus 2 equals 12. Then I'm going to subtract 2 from both sides. So 5b is equal to 10. Finally, I'll divide both sides by 5 to get b equals 2. Number 27, same kind of deal here. Nothing really different than what we've seen before. We'll start by adding 3k to get all those variables on one side. 7k plus 3k is 10k, plus 24 equals negative 16. Then I will subtract 24 from both sides. Negative 16 minus 24 is negative 40. I did put that in the calculator. Don't think I'm like some kind of genius or anything. Going to make sure we get the right answer. Divide both sides by 10. So I get k equals negative 4. Let's take a look at 28. Now here we've got a lot of stuff going on. We are going to have to move. We got variables on both sides. We're going to have to deal with that. But before we start doing any properties of equality, we want to combine like terms. And by the way, this might be a good opportunity to just kind of go through like the order of the steps that you want to take here. If there's a distributive property, you want to do that first. Now on number 28, 29, there's no distributive property. But if you see a set of parentheses, like you see down there on 30 and 31, you're going to do the distributive property first. And we did already work a few that had that distributive property in it. Then you're going to combine your like terms. That's where you collect all the, like if you've got multiple terms with the same variable on one side, pull them together. If you got multiple constants on the same side of the equation, pull them together, add them together. So you're going to combine like terms. And then finally, that's after you do those first two steps, then you start using your properties of equality. Okay, so this is generally the order of how you want to do the steps. Not every equation is going to have the distributive property or have like terms to combine, but if they do, this is the order that you want to do them in. So 28, we're going to start with there's no distributive property. We're going to go to combining like terms. There are two like terms we can put together, this 8h minus 3h, which is 5h. So now I have 5h plus 5 equals 8h minus 4. Then I want to get all those h's over to the left-hand side, so I'm going to subtract 8h to get rid of it on the right-hand side. 5 minus 8 is negative 3, so I get negative 3h plus 5 equals negative 4. Then I'm going to subtract 5 from both sides. And that leaves me with negative 3h equals negative 9. Finally, I'm going to divide both sides by negative 3 to get h equals a negative divided by a negative is going to be positive 3. Number 29 will work very similarly here. It's actually set up just like number 28. We're going to combine our like terms. Whenever you have a variable that doesn't have a coefficient in front of it, like that initial g, there is an implied 1 here. So if it helps, just anytime you see a variable with no number in front of it, with no coefficient, throw in a 1. You don't have to write it, but sometimes some students find that helpful. Okay, so 1g plus 7g is 8g's, minus 10 equals 15 plus 3 more g's. Next, I'm going to subtract 3g from both sides to get 5g minus 10 equals 15. All those are multiples of 5, so kind of like where the arithmetic's going here. Add 10 to both sides. 5g equals 25. And then if I divide both sides by 5, I get g equals 5. Okay, 30's got some distributive property thrown in there. So does 31. Always want to do that first. So we're going to distribute that negative 3 here. Negative 3w minus 12 equals 4w minus 5. Next, we'll subtract 4w from both sides. Negative 3w minus 4w. A lot of negatives there. I keep saying this over and over again. Probably get tired of me saying it, but use a calculator for the arithmetic. Negative 7w minus 12 equals negative 5. Now, if you're thinking, I don't know how to use a calculator to do that, right? Like, there's no W button on the calculator. How do I do that with the calculator? Well, anytime you're combining like terms like that, you could just add up the coefficients. So you really be typing into the calculator -3 minus 4, okay? And just know that the variable is not going to change. It's still going to be W. Next, I'm going to add 12 to both sides. Let's move this up a little bit. -7W equals, let's see, 12 minus 5. I think that's just 7, isn't it? Yep. Divide both sides by -7. And our answer here will be -1. Over on 31, we'll distribute that 10. And we actually need to do a little distributive property over here on the right-hand side, too. Might as well knock them both out at once. 10G plus 50 equals 2G plus 18. Then I'm going to subtract 2G from both sides. That gives me 8G plus 50 equals 18. Then I'm going to subtract 50 from both sides. 8G equals, let's type that one in, 18 minus 50, -32. And then finally, we'll divide both sides by 8. There we go. G equals -4. Okay, moving on. We got some more practice. I think this is the last page. Okay, great. Okay, so let's take a look at number 32. We'll distribute the 5. We also want to distribute the 1/2. So we'll do both of those. Let's see what happens here. We got 5 plus 10m equals 4 plus 10m. Now, if I subtract 10n from both sides here, something weird is going to happen. All the variables are going to cancel each other out, right? 10 minus 10, 0 on both sides. So what I'm left with here is 5 equals 4, which obviously is not true. That is a false statement. Now, any false statement, any statement that, if you're working out these equations and all the variables drop out and you're left with some equation that just can never be true, right? 5 is never equal to 4. This is what's known as a contradiction and will have no solution. Basically, what that means is that there is no number that you could plug into m up here, no number that could go here and here that would make that true. So there's just no answer. For number 33, I'm going to start with that distributive property again. Distribute the 3, distribute the 2. And here I've got 12G plus 18 equals 12G plus 18. Now, if you ever notice that you get the exact same expression on both sides, you can basically be done. If you don't catch it and you happen to subtract the 12G from both sides like you would normally do, you're going to get all the variables to cancel out like on number 32. But the difference here is we end up with a true statement. All right, you see, if on any of these linear equations, when you solve it, if all the variables cancel out, then you're either going to end up with a true or a false statement. If it's false, like number 32, there's no solution. But if you end up with a statement that's always true, like any equation where you have the exact same thing on the left and the right-hand side, you can just stop. And that's because any number would be a solution. You could plug in any number you want to both of those G's and have a true statement. So we're going to say that there are infinitely many solutions. Okay, so these are just two special cases here. Now, the last couple of problems on the homework, these are going to be more like what you see on the TSI A2. The rest of these solving, this is all good practice, and I want you to know how to solve. It's just going to be a useful skill in pretty much every math class you're going to take from here on out. But the actual questions on the TSI A2 are multiple choice. So while you should know how to solve these by hand, I also want to encourage you to take advantage of the fact that they're multiple choice. And what I mean by that is, let's say like a number 34. If we just want to solve for k, we could definitely do that by hand, right? 2k plus 1 equals 12. This is not even like one of the harder ones we did. You just subtract 1, and then you're going to divide by 2. 11 doesn't divide by 2 evenly, so you're just left with a fraction, 11 halves. Right, so our answer here is going to be D. But you don't even have to go through that algebra really on these multiple choice questions. Just if you want to skip all the algebra, just go straight to the answer. Just check each answer choice one at a time. What I mean by that is, like, use your calculator, type in 2 times 2/11ths plus 1, and if it equals 12, you know you got the right answer. If it doesn't work, go to the next answer choice. And on this one, you'd have to go all the way to choice D unless you just happen to pick that one first. You plug in that answer choice. 2 times 11 over 2 is 11. 11 plus 1 is 12. And that's the only one that is going to work for that equation. But no matter how complicated these solving problems are, and we're going to get to ones more complicated later in the year, if the problem just boils down to solve for x, or like solve for k in this instance, you can always use the answer choices to your advantage and just plug them in. And there really is no reason why you should get those wrong with a calculator. Okay, number 35, it says if x plus y is 24 and x equals 2y, then what's x? Well, if x is 2y, then I'm going to rewrite this equation, x is 2y, as 2y plus y equals 24. 2y plus y, those are like terms, so I can combine them. 2y plus y is 3y. 3y is 24. And then if I divide both sides by 3, I get y equals 8. Now be careful here. 8 is not going to be our answer. You might be tempted to throw in that 8, but 8 is y, and this question is looking for x. So if x is 2 times y and y is 8, that means x has got to be 2 times that, and therefore is 16. Now you can check your answer here. It says x plus y is going to be 24. Well, 8 plus 16 is 24, so that works. And also x has got to be 2 times y, and 16 is 2 times 8, so that checks out as well. Just make sure you're reading that question carefully. Number 36 is, which of the following is not equivalent to 12y minus 24? Well, here we're just going to plug in some number for y and see if it works. Okay, there is some factoring going on here. And honestly, this problem probably doesn't fit in the whole category of solving linear equations. We'll come back to factoring later in the year. But I do just want to show you a test-taking technique here that can work for a lot of these problems. Anytime you're trying to answer an equivalence question, like which of the following expressions is the same as this, which is like number 36 is, you can just pick a number for y. So I'm going to pick 2. Okay, it doesn't have to be 2. It could be any number. And just plug it into the y. Okay, so 12 times 2 minus 24 is 0. Okay, 12 times 2 minus 24 is 0. So if I plug in 2, 3 out of the 4 of these answer choices are going to equal 0. And so let's start with A. 2 times 6 times 2 minus 24. Well, 6 times 2 minus 24 is negative 12. And negative 12 times 2 is negative 24. So I think we actually found our answer right away. It's going to be A. That did not equal 0. I don't even care what it equals, but it wasn't 0. But let's just double check. Sometimes you make a mistake. Typing in the calculator does not hurt to go back and check, especially because this test is not timed. You get as much time as you want, so take advantage of it. Let's check the next one. 2 times 6 times 2 minus 12. 6 times 2 is 12. 12 minus 12 is 0, and 0 times 2 is 0. You can also just throw it in your calculator. C, we've got 4 times 3 times 2 minus 6. 3 times 2 is 6. 6 minus 6 is 0. Again, we get 0 for C. And lastly, we get 12 times 2 minus 2, which obviously 2 minus 2 is 0. So our answer is going to be A. Now, this can work on any equivalence question. If you're ever asked to say, which expression is the same as, which other one, try this method out without trying to work too much algebra, because they can be very easy if you approach it this way. Finally, number 37 says, if 8k minus 6 is 4k, then what's 12k? Okay. Okay. So we want to know 12K. Now we know 4K is this. But what about 12K? Well, let's find out what K is. 8K minus 6 is 4K. We could subtract 4K from both sides to get 4K minus 6 equals 0. Then we can add 6 to both sides, and we get 4K equals 6. And then finally, we're going to divide both sides by 4. Now, 6 doesn't divide by 4 evenly. You can reduce it, but it's really not necessary. We know 6 is 6 over 4. If you throw that in the calculator, you'll find that's 1.5, although you don't really have to do that. Now, the question here is what's 12K, not what's K. So we're going to take that K value and multiply it by 12. Okay, so 12 times 1.5 is 18. So our answer is C. So just a little sampling here of what's been on TSI tests in the past. I'm gonna try to integrate TSI A2 questions on just about every homework we have. So keep an eye out for those questions to really give you a clearer picture of what to expect on that test. But that's it for today. Please reach out if you have any further questions. You can always reach me, catch me in the morning for tutoring, send me an email, comment on this video, somehow reach out if you're needing a little extra help, and I'll be glad to help you. But other than that, y'all have a great day. I'll see you next time.